Imagine you're trying to keep track of dozens of zombies in a video game, all their health, speed, size, and strength using just variables. Sounds like a nightmare. What if I told you there's a much easier way? Stick around and I'll show you how Python classes can make your life much easier. Magandang araw, ako si Kuya Code. Welcome back to my channel where I teach Python through coding challenges on HackerRank. In this video, we'll talk about classes, why they're useful, and how they can help you organize your code better. Then we'll tackle the first class challenge on HackerRank. By the end of the video, you'll know how to create your own custom object in Python. So firstly, what is a class? Think of a class as a blueprint similar to a named tuple. So if you haven't watched that video, go and watch that and then come back to this one. Anyway, just like a blueprint for a house, a class defines the structure of an object. But a blueprint itself is not the house, it's just a template. That way you can make a bunch of houses that are all copies of each other and look the exact same. So in Python, we use classes to create objects, like a blueprint is used to create a house. So why use classes? Well, they organize data and behavior so they're all similar. You can easily use code and then make programs easier to understand and maintain. So I'm just going to write a simple one here. This is like the absolute bottom base of a class. So first, I'll actually make this a bit bigger. And then I will show the lines here. So first I'll do class, I don't know, demo. So first we'll have a method called new. This is a method, normally you don't necessarily need to define this because it's automatic. There are certain cases for making things like singletons, which is something more advanced for this video that I'll talk about in a different video. But just as an example. So this basically is what's called when you first create, like this creates the object. So for example, we can just put a print statement here that just say object created, like that, something simple. And then you can just do return super new, which is just the original one. CLS stands for class. And then the next one is just one that you would generally always see is just the init, which is initiate. This initiates the object. We can just pass in self. And we'll just print method in init. All right, and now we can just create the object. So this is basically the blueprint. So every time we make a new object, it's going to look like this. So we can just simply make an object, call it whatever we want, call it new object, and then we do demo. So this is just the name of the object you're making, and this is just basically, this is the where you put parameters just like in a regular method. So normally whatever you put in here gets passed into the init. So you don't actually have to include self because that's automatic. But let's say if you were to put like an x and a y, if you wanted to add something together like two numbers, you would just do 1 and 2, and then these two would be mapped to x and y. But that's something we don't need for this section here. So we have our new object, and just that alone is going to call the new to create the object, and then it's going to call init to initialize it. So if we go ahead and run that, we have object created, and then we have method init. So that's exactly what we were expecting. One thing else is that I think I mentioned it before, but these are called dunder methods, which is double underscore. These are these methods act as a contract between the Python interpreter and the person who made the actual class. So for example, a person who made the int class defined the add method to let Python know that the plus symbol works on the int object. So it would, I won't actually do the whole thing, but when I mean the add method, they have there's a dunder called add, and they defined it that way. You don't actually need to call this. It just lets it know that when you use plus, it'll automatically just call the add dunder. In the Python or the HackerRank coding challenges, there is something similar to that. So in this next section, let me go ahead and delete this. We'll just make something that's a bit more practical. So we'll just call it dog for this class. And there's something called a class variable as well as an instance variable. So firstly, we'll do this. Species. It's canine. And then we'll just do our init method. self, and then we'll give the dog a name, and then we can do self.name equals name. And what this means is that whenever we create a dog object, the dog object will have their own name. So every single object will have a different name, but then every single dog object will share this specific property, which is just the canine species. So if we were to go ahead and print that out, or go ahead and make an object, so we got dog, dog1 equals dog, and like I said, the self is automatic, but because we need to provide a name for the init, we can just type in a name here, like Max, and then we'll just make a second dog here as well. So this is dog2, and we'll do buddy. So now we have two objects here. So like I said, each dog is going to have a different name because this is a variable that's unique to each specific object. But then this property is going to be shared between all of them. So we can just print out dog1 dot species, and then dog2 dot species, and then we could just also print out dog1 dot name, and then dog2 dot name. So we'll go ahead and run that. I forgot the the colon here. So of course, dog1 and dog2 both have canine for the species, but dog1 has Max for the name and dog2 has Buddy for the name. And one other thing that I wanted to mention, kind of related to the dunders, it is useful to override, and that just means that some of these objects have defaults, and when you define a dunder inside of your class, you can replace the default. So what does that mean? So we'll just go ahead and delete this. If I just print out dog1, this is what it's going to give us. It just gives us a bunch of garbage that's not really very useful. And that's just what the default gives us. That's part of the dog class. So basically it just turns this into a string and then just returns the string. But we can actually have a dunder string, and then what we can do simply is override it by simply returning I have a dog named, and then we could do self.name, and we need to format. So now this is overridden. So now if I print out dog1, it's going to do something different. It doesn't say this anymore. We overrode it and replaced it with whatever we want. There is one other thing. This one is generally for like the user. There is another one called I think it's REPR, which is more of like, you know, debugging purposes. I guess an example, if I have a list like this, dog1, dog2, and then we could print out LST. I'll just remove this for now. So even though doing print dog1 does return this string, if you have it in a list and you do it and you print out the list, it doesn't work. It still gives us this stuff. But if you have it like this is kind of for, you know, debugging purposes, what they always say. You can copy and paste this, and we can do the same thing, and what should work. Let me close this. I think I did it wrong. Yes, I forgot the underscore. There we go. So now it shows it shows it properly because it shows both of these inside the list. And now I'll show you one more example that's a bit kind of more in depth, or at least a bit longer. So we'll have another class called bank account. We'll have a static variable, which is bank name equals Python National Bank. And then we can have our init. Self, we'll have an owner of the bank account, and then we'll have a balance. If you have it just like this, you have to provide it when you make the object. If you put an equals and make it something like that, this is a default. That way, if you don't provide it when you make the object, it'll just default it to 0. Because otherwise, it'll just give you an error if you don't have, if you're not having a default, then you just ignore it. So we'll just have that. So of course, self.owner equals owner. And then self dot balance equals balance. And then we'll just have two more methods here. So deposit self amount, the amount to deposit, which can be self.balance plus equals the amount that we pass in. And then we'll just have a print statement here. So pass in the print statement, and then we'll do another one, click withdraw, self amount, self.balance. I realized I spelled that wrong. Minus equals amount. And then we will do withdrew the amount. And then we can also do, oh, this is something obvious. If you don't have like overdraft protection, when you try to draw an amount that's more than what is in your account, we'll have to have some message of that you don't have enough money. So before actually taking out the amount, we need to check if the amount is more than self.balance, then we need to print not enough cash. Actually, that seems kind of weird. It seems like the ATM doesn't have enough cash. We'll just do insufficient funds in account. And then else, if I can type, then we will go ahead and take the amount out. So that looks good. And then of course we'll just do our dunder for the string again. So def string self. So what do we want to do if we just simply print out the object? We'll just have a generic message to just return a statement about the owner and the actual account. And because this is I guess I didn't mention that before, how it should be done. Because before in the dog example, I just put dog1.species. But what you could do, or what you probably should do, is because this variable is not associated with any object, it's associated to the class itself, you would actually do the class name. So rather than doing, the name of the person or the name of the object, you would just do the class name itself dot, the variable. So that's a bit better way to do that. So now that we have our class, we can go ahead and do some prints out here. So account equals bank account. And then again, we need to pass in, well, actually, if I do it like this, you'll see that it should give us an error. I forgot about that. It gives us an error because we are missing one required positional owner. So because owner doesn't have a default like this, it's required. So if I just do like that, now this one is taken care of. This one we don't need. It still works, as you can see. But I can still, put in 100, and then the balance would be updated to 100. You can just do print account dot balance, and then it would show it as 100 instead of 0. So that is our account. I will get rid of this. First, we'll do account dot deposit, which is deposit 50, and then account dot withdraw 30. So if we start with 100, we add 50, which gives us 150. We subtract 30, which gives us 120. But now we'll do account dot we'll withdraw 200. This is not going to work because it's going to give us insufficient. It'll give us this insufficient funds in the account method, and then we'll just print out the total balance, just to actually show that it doesn't work. So account dot balance, and then we can just simply do print. Actually, we'll have to print balance. We can print account just so we can test out this, and then we could also print bank account dot bank name to test out the fact that this works with the actual class name and not, you don't have to do it that way. So go ahead and run this. So let's see here. So so you deposited 50, you have 150, you withdrew 30, you now have 120. Insufficient funds in account. This is just the account balance, which is 120 because of the 200 that we tried to draw out didn't work. And it says Richard's account in that Python National Bank, balance 120, and then Python National Bank. So that looks good. So now we'll just go ahead and go to the challenge here. Give me a second to open it. The challenge on HackerRank is a bit weird because it kind of deals with things that are not necessarily beginner friendly. You'll see in a second when I pull this up. So in this example, we're trying to make a class that will calculate different things related to points. So we have given 4 points, A, B, C, and D, in a 3D dimensional Cartesian coordinate system. And we have to calculate the dot product, the cross product, the absolute, and also we needed to override this dunder, which is for subtraction. So don't really worry about any of this math. We're only going to also kind of explain the difference between dot product and cross product just for the sake of it, but I wouldn't really worry about on the math too much. We're just kind of worrying about, writing these methods. So the first part is obviously initialization. So we have x, y, and z. So self.x equals x, self.y equals y, and then self.z equals z. That's good for the initialization. So for subtract, normally if you have a and b, and you just use the subtract operator, it knows what to do. But if you have point A and point B, and each one has 3 variables, it doesn't by default know what that means. So we need to define what this means. So what I'm going to do here is just return a new points, and then we can simply do self.x subtract no.x, which is no is just the other point that you're comparing to it, and then self.y subtract no.y, and then we'll do self.z subtract no.z. That's good for that. And then for dot product and cross product, I'm just going to show an image here that kind of explains the two. So look at this graph here. We have 3, 4, and we have 2, 1. So the dot product tells us how much 2 vectors are going in the same direction, or whether or not they're going in the same direction. As you can kind of tell with these 2 lines, they kind of generally are going in the same direction. But an easy way to explain it is that the angle that we have made from these 2 lines is, if it's less than 90 degrees, it's an acute angle, and if it's more than 90 degrees, it's called obtuse. And there's a formula that we can write that calculates whether it's, acute or obtuse. And generally, if the formula gives us a positive number, that means that it's a acute angle less than 90 degrees. If it gives us exactly 0, then it's exactly 90 degrees. And if it gives us a negative number, then it's more than 90 degrees. So for example, with this, we have 3, 4, we have 2, 1. So first I'll just write out the formula just so you can kind of visualize it a bit easier. So for dot product, we have self.x. Actually, we'll have to do return self.x. Multiply that by no.x. And then we can add self.y multiply by no.y, and then self.z multiply by no.z. So that is basically what we have. So if we look at the actual graph again, So we have self.x, which is 3, multiplied by no.x, which is 2. That's 3 times 2, which is 6. And then you add that to 4 times 1, which is 4. So if you add 6 to 4, we get positive 10. So of course that would be an acute angle. But let's say this 2, 1 is down here off the screen. It would be negative 2, negative 1. Well, in that case, we have 3 times negative 2, which equals negative 6. We have 4 times negative 1, which equals negative 4. And when you add negative 4 and negative 6, you have negative 10. So because it's a negative number, you know that it's an obtuse angle. And then likewise for the right angle, if it's down, if this point is moved down here to be positive 3 and negative 4, in that case, it would be make a right angle. But if we take 3 times 4, that would give us 12, and then 3 times negative 4 would give us negative 12. And when you add positive 12 and negative 12, you give us 0. So whenever the dot product is exactly 0, you know that it's a right degree, a right angle, sorry, a 90-degree angle, or I guess a right angle works too. So that's what the dot product is. For the cross product, the cross product is generally only for 3D objects that have 3 variables, but for the third point, you can just literally have it as 0 and it still works. So again, back to this photo, we have 3, 4, and 0 is the first one, 2, 1, and 0, which is the second one. So when you do the cross product formula, which I'll do in a second, we get negative 5. And what the cross product tells us the rotation between two vectors that going when you go from the first one to the second one. So if you start in the red one and you want to rotate to get to the black one, then you're going clockwise. But if this was on the opposite side, then you would go counterclockwise. And if they're right over top of each other, the result would just be 0 because they're just parallel. So I'll do the formula. I'll just paste the formula in here first to just save time. I don't actually have a thing for cross self no, and this is this looks like. So we have self.y times no.z minus self.z times no.y. You know, this is basically what the formula is. And so when you do the math for this one, you get negative 5, and because it's a negative number, it's clockwise, because going from the red to the black is clockwise. And if it would be the, if this was 1, 2, which would be over here, and you do the same formula, that would give us a positive 2. And a positive number means that it rotates counterclockwise. And of course, if you have, let's say, you know, 1, 1 and 2, 2 for your 2 points or 2 vectors, those are obviously parallel because they're on top of each other, and when you do the formula, it'll just give you 0. And then for the last thing, absolute is basically just takes any number and changes it into a positive number. So we can just simply do this. You take a number and you square it, and then you would get the square root, and that would always give you positive. So for example, if you have 2 and 2, well, 2 to the power of 2 is 4, and you add that to 2 to the power of 2 is 4, but then when you square root it, you'll just get 2 again. Or if you have a negative number, like negative 2 squared is still positive 4, and then when you square it, it would still give you positive 2. So like I said, taking the absolute of a negative 2 would give you 2, and then the absolute of a positive 2 would still get you 2. So that's basically what it is, or what the formula is for the absolute. And then in Python, you can literally just do ABS. It's like one of the built-ins, so you don't need to do this formula every single time. You could just literally do ABS and then just type it in. But that should be it for this. So let's go ahead and submit this and see what we get. All right, so we got the right answer with that, and we'll go and submit this. And it looks like we are correct. So like I said, don't worry about the math too much. This is just how classes the basics of classes. But that's it for this video. If you found this video helpful, please like and subscribe for more coding challenges, and let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Paalam.